In this video, I will explain how to solve a typical relative velocity problem in physics that involves a boat crossing a river. So let's jump right into this example. This says, a boat is heading due north as it crosses a river. The velocity of the boat is 10 kilometers per hour relative to the water. The river has a uniform velocity of 5 kilometers per hour due east. Find the boat's velocity and direction relative to an observer on the riverbank. So I've gone ahead and sketched out this situation. So we have this boat here. It wants to travel from one side of the river to the other, and we're told that the velocity of the boat relative to the water is 10 kilometers per hour. So the boat is heading due north. So I've gone ahead and drawn a vector right here that shows that the boat is heading north, and I've also labeled it showing that the velocity of the boat relative to the water is 10 kilometers per hour. So that's how we interpret this value right here, the velocity of the boat, which I've labeled B, relative to the water, and that's 10 kilometers per hour. Now, we also know that the velocity of the water is headed due east. So I've drawn a little compass here to indicate our directions. So east is in this direction. So I've labeled this as the velocity of the water, W, relative to the ground. So the ground I'm calling the riverbank right here, because remember, we're analyzing this problem from this person's point of view on the ground. And that value is 5 kilometers per hour. And again, it's going east. So this vector I've drawn headed east. Now our question is, what is the boat's velocity relative to this observer on the ground over here? So I've gone ahead and drawn another vector right here that indicates the velocity of the boat relative to the ground. So this is what we're interested in figuring out. So what we'll notice about this situation is that although the boat is headed north, since this water is pushing it east, ultimately the boat is going to be drifting towards this northeast direction. So this vector right here describes the path that the boat will actually take. So notice what we've done here is that we've actually drawn a triangle, and specifically it's a right triangle where this is a 90-degree angle. And what we're interested in finding is this value right here, which represents the hypotenuse of the triangle. So actually all we have to do to solve this problem is use the Pythagorean theorem, which says that the hypotenuse squared is equal to the individual sides squared added together. So here's what we can write. We'll say the magnitude of the velocity of the boat relative to the ground squared, so this is our hypotenuse of the triangle, is equal to, we can take these two values squared and added together. So we'll say the magnitude of the velocity of the boat relative to the water squared plus the velocity of the water relative to the ground squared. So now if we want to figure out this value, we can just take the square root of each side. So that will get us the velocity of the boat relative to the ground is equal to, we'll have the square root of, we'll have the magnitude of the velocity of the boat relative to the water squared plus the magnitude of the velocity of the water relative to the ground, and that's also squared. So let's go ahead and fill in the values that we know. So we get the square root of this magnitude right here, we know that's 10 kilometers per hour. So we'll get 10 squared plus this magnitude right here, that's 5 kilometers per hour. So we have 5 squared. So we get 10 squared is 100 and 5 squared is 25. So 100 plus 25, that's the square root of 125. And that turns out to be about 11.18, and we'll say kilometers per hour since we're talking about velocity. So this velocity of the boat relative to the ground, so relative to this observer's point of view, is 11.18 kilometers per hour. So let's go ahead and box that in. Now we also want to know the boat's direction relative to the observer on the riverbank. So in other words, we want to know what is this angle right here. So the boat is heading north, but it will drift east. So we want to know what angle is this going to be relative to this observer's point of view. So there's a few different ways to find this angle. One way to do it is to recognize that the tangent of this angle is going to be equal to the opposite side of the triangle, which would be this side right here, divided by the adjacent side, which would be this side right here. So here's what we can say. The tangent of that angle is equal to 5 divided by 10. Now to actually find the angle, we can take the inverse tangent of each side. So here's what we get. The angle is equal to the inverse tangent of 5 divided by 10. And 5 divided by 10, that can be simplified to 1/2. So if you punch this into a calculator, the inverse tangent of 1/2, and make sure your calculator's in degree mode, that comes out to about 26.57 degrees. So that's what this angle is right here. And we can also specify, if we want, that this angle is east of north. So again, the boat is heading north, but it's drifting slightly east. So let's just specify that this angle right here is east of north. So that will be our final answer for this particular problem. So again, keep in mind that when you're trying to solve these types of problems where a boat is crossing a river, try to first draw a right triangle. Because once you've drawn a right triangle, it becomes very easy to solve for any missing side lengths or missing angles that you want to find.